of a confined system between where we have active growing cover crops and where we had terminated cover crops. We're going to look at some of the soil moisture differences in those two spots. So just so you know that I'm not an agronomist just jumping in a soil pit, all of my PhD training is actually in pedology. I married an agronomist and then had to switch jobs. So this is going back to the old science. So as we were digging through this morning, we can find a lot of roots. Most of them are in the very fine to fine, which is our smaller roots that we would expect for a lot of these crops. We do have one or two that are getting a little bit larger. They honestly probably came from the pigweed, for being truthful. So, but they are there. When we're in this actively growing area, this was mowed down on Tuesday. So we can still see some of the recently live roots at the front. When you have an active crop, it's the main thing using that water. So that's always something to keep in mind, is those plants were what have been taking the two rainfalls that we received recently. And so as you dig through this area, take note of how hard this soil is to dig into. We haven't had a lot of rainfall. The plants are trying to take up any of the available water that they can actually reach. So when we move further down, where we still had cover crops earlier this summer, they've left all of those roots. They're still breaking down. So we have active root channels, and by active I just mean that the root material is still in the soil channel, which is preventing soil sediments from backfilling those root channels right now. So then whenever we're getting rainfall that we received after that crop was terminated, all of that moisture is actually able to go into the subsoil and start to build up some saved water for our following crop. If you follow Katie Lewis, Josh, yeah. She's at Texas Tech and Texas A&M, sorry. They've been doing some research in cover crops going into cotton. And so on some of their Twitter pages, X, whatever you want to call it nowadays, they had some trials from this summer where the cotton that was not following a cover crop was surviving the drought. The cotton following the cover crop was having some water issues because it didn't have the same water profile as where there wasn't a cover crop. So something to always keep in mind when we are in more semi-arid to arid environments, that water balance you really have to watch, because we're playing a different game with our water than some other areas in the United States. Yep, constantly. So as you'll come in, this side where we've got our actively growing cover crops, it's going to be a lot harder to dig. As we move down there, we've got some areas, there's a water bottle and a screwdriver. It's friable, so we can break into it easily. It's got some good moisture. It's a good picture for how that's going to be set up for as you start to get ready to plant in September for your winter wheat. For this soil, we're on a Norge. This is a silt loam surface. This is a Paleoustol. So all that means is we've got a really old mollisol that's got an oustic soil moisture regime, which ranges kind of into that somewhat moist to semi-arid climate, which is kind of what we expect to find in this central part of Oklahoma. So this is a mollisol, and that's one thing that a lot of Oklahoma, we're a prairie state, and so the majority of our soils were mollisols. It's just how much has stayed around after the Dust Bowl. That's what we're kind of balancing. So if you want to take a look at the soil color, we can. So if you grab any of the surface soil and moisten it down, At least on the piece I grabbed earlier, I got a 5YR33. When we're dealing with mollisols, we would expect those colors to be in this lower portion of this page. So you have to have a 3 or less to actually fall into a mollisol category. There's a lot of other stuff, but that goes into the lab, so we can't do that out here. So it does still qualify for that. We also look at depth of that horizon for our Moloch epipedon. But even though it still has that reddish color that we're getting on that yellow-red page, it still is a deep dark color. So it is still showing up as that Moloch color in this soil. When we get a little bit further down, we get into some of that lovely Oklahoma deep red. So at this point, it gets into a BT horizon. So you've got clays that have moved down through those soils. And so when you have those clays, just keep in mind, if you've got the moisture and it stayed moist, you're awesome. If it's dried out, you have bricks in your soil at that point in time. So that's the good and bad with clay. It can hold a lot of moisture, it can sustain your plants. As soon as we start hitting dry periods, you would wish that you didn't have any clay in your soil profile at that point in time, because the clay is going to hold on to all of the moisture. The plants, it's no longer plant available because it's held too tightly on the soil. Okay, so jump in. We've got a few screwdrivers placed around. That one's going to be the more enjoyable one to dig through. The spray bottles will help you with some of the soil colors to kind of see any transitions down. Don't stab yourself. I don't have a scar from soils judging, but I did stab myself in Arkansas, so be careful.